How does bias propagate in NLP models? Imagine teaching a child to read by showing them a huge library of books. If most of those books have stereotypes or unfair ideas, the child might learn those too. That's similar to how bias spreads in natural language processing models. These models learn from large collections of human-written text, like internet articles, books, and social media posts. If these sources contain biased language or stereotypes, the models pick up on those patterns without realizing they are unfair. When a model is trained, it looks for relationships between words and concepts. For example, if the training data shows that the word doctor is often paired with he and nurse with she, the model might start to think that doctors are mostly men and nurses are mostly women. This is because it learns statistical patterns, not moral judgments. The architecture of the model also influences how bias spreads. Transformer models, which are used in systems like ChatGPT, use attention mechanisms to focus on important words in a sentence. These can sometimes reduce bias, but they are not immune. If the training data is biased, the model can still learn and reproduce those biases. During training, the model doesn't decide what's fair or unfair. It just learns what is most common in the data. So if society has stereotypes, like associating leadership roles with men or certain nationalities with specific traits, the model will likely reflect those. For example, if most examples in the data show men as leaders, the model might generate text that assumes men are more likely to be in charge. The same thing can happen with images generated by models like DALL-E or Midjourney, which relying on language understanding. They might produce images showing only men as CEOs or only women as teachers because of the stereotypes in their training data. Detecting bias in NLP models is an active area of research. People analyze the outputs to see if the model favors certain stereotypes or underrepresents others. They test how often the model makes stereotypical associations versus fair ones. There are tools to measure these biases, but it's not always easy because biases can be subtle and hidden in the data. Addressing bias involves careful steps. One way is to balance the training data so all groups are fairly represented. Data augmentation can add synthetic examples to fix imbalances. Models can also be fine-tuned on more balanced datasets after initial training. But removing bias completely is tough because language reflects society's views, which are always changing. New biases can appear as language evolves and new topics emerge. Understanding how bias spreads in NLP is important because these models are used in many real-world applications. Chatbots, content creation tools, and even hiring systems can produce biased outputs that reinforce stereotypes or exclude groups. This raises ethical questions about how we develop and use these technologies. For example, if a hiring tool favors certain demographics because of biased training data, it can unfairly exclude qualified candidates. Popular tools like ChatGPT, DALL-E, and Midjourney show us what modern AI can do, but they also reminded us that bias is a real issue. Users and developers need to be aware that these models reflected the data they learn from. Checking for bias and working to reduce it is part of responsible AI use. In the end, understanding how bias propagates in NLP models helps us build fairer, more trustworthy AI systems that serve everyone better.